This is Mr. Beck Does Your Homework. This is physics homework number 7 about trig and horizontal projectiles. Questions 10 through 13, a four-part question. Question 10 says, a ball is thrown horizontally from the top of a building 29.3 meters high. So let's start drawing this. There's my building, there's my ground. I know this is 29.3 meters tall. The ball strikes the ground at a point 95.6 meters from the base of the building. So I know that when this thing does its flight, this is going to be 95.6 meters from the base of the building. So my ball is going to travel down and it's going to fall and it's going to hit the ground. The acceleration of gravity is 9.8 meters per second squared. So now I should take this information before I do anything else and figure out what I know in the x world and the y world for this problem. I'm not even going to look at the questions yet. So in the x world, things that are happening horizontally, I know that my acceleration is 0 meters per second squared. In the y world, I know that my acceleration is gravity. And gravity in this case is negative 9.8 meters per second squared. What else do I know? I know that in the x world, there's 95.6 meters that it's going to travel horizontally. So I know that x equals 95.6 meters. In the y world, I know that it's going to fall 29.3 meters. So I know my displacement in the y world is going to be negative 29.3 meters. It's going to fall down that far. I know my acceleration, my distance, my acceleration, my distance. Find the time the ball is in motion. Well, I'm going to be looking for a time. I don't know the time over here. I don't know the time over here. That's what I'm looking for. Do I know anything else about x world and y world? I do, because it's thrown horizontally. If it's thrown horizontally, that means that all the velocity is in the x world. I don't know what that velocity is, but I know that whatever it is, this velocity is all horizontal velocity. So that means it has no vertical component. So I know that my initial velocity in the y direction is 0. Now, with an acceleration, a displacement, looking for time with an initial velocity of 0, I can solve for the time the ball is in motion. So, for the time the ball is in motion, for question number 10, I'm looking for time. That's a y world problem, so I'm going to use this information. I know that my displacement is my initial velocity times time plus 1/2 my acceleration times time squared. For horizontal projectiles where my initial velocity is 0, this term goes away and I can rearrange this equation. So multiply by 2, so I get 2y divided by gravity. That's going to be equal to t squared. So if I square root both sides, that's my time, is the square root of 2y over g. So that's going to be the square root of twice my negative 29.3 is my y, and my g is negative 9.8. When I do that, this will be positive, so I'll find the square root of a positive number, and that will give me time. So that is my answer to question number 10. Question 11 says, find the initial velocity of the ball. Well, the initial velocity in the y world is 0, but now I'm looking for this initial velocity in the x world. How do I find the velocity? Well, I know in the x world that my velocity is my displacement divided by my time. In my x world, I don't have any acceleration, so this equation works in the x world. Well, I have my displacement is 95.6 meters. And my time is this time that I just solved for right here. So if I have 95.6 meters divided by this time right here, that's going to give me my velocity. So that's the answer to question number 11. The initial velocity is all x world, so that x world velocity is the initial velocity. Question number 12 says, find the x component of its velocity just before it strikes the ground. So when it hits the ground, it's going to be moving in the x direction, and it's going to be moving in the y direction. So it's got a final velocity in the x world, which I'll call vx, and a final velocity in the y world, which I'll call vy. So it's looking for the x component of the velocity. Well, I know that my initial velocity in the x world is this. So if this is my initial velocity, What's my acceleration in the x world? It's 0. So if this is my initial velocity in the x world, this is my final velocity in the x world. So that's also going to be my x velocity. So my x component of velocity just before it strikes the ground. Now I've got question 13, which says find the y component of its velocity just before it strikes the ground. Well, it's going to be going down, so I got to watch out. It's going to be negative. But I know that my final velocity is my initial velocity plus my acceleration times my time. So my final velocity is going to be my initial velocity of 0 plus my acceleration is negative 9.8 times my time, and my time is this that I solved for before. There's my time. So when I do that, I will get a number, and it's going to be negative, so make sure you enter it as negative.